We're going to jump right into some examples. The last topic we finished with in the last lecture was dealing with the t-distribution to construct confidence intervals, and we're going to continue with more questions like those. Example 9.3. A professor in the English department would like to estimate the average number of typing errors per page in term papers for all students enrolled in liberal arts English courses. So notice that it says the professor would like to estimate the average typing errors for all students. So the professor is basically trying to estimate a population mean. For a random sample of 36 term papers, the professor found the mean number of typing errors per page was 4.6 and S equals 1.4. So in this sentence, we learn that N is 36, and in that sample of 36, the mean of that sample, or X bar, is 4.6, and the standard deviation of that sample is 1.4. Find a 95% confidence interval for the mean number of typing errors per page for all students enrolled in liberal arts English courses. So you're going to use the t-distribution because we don't have the population standard deviation. We have the sample standard deviation. So we're definitely going to be using this formula, x bar minus the t-score times s over the square root of n to x bar plus the t-score times s over the square root of n. S is used as opposed to sigma for the population standard deviation. We don't have it, so we're using S, the sample standard deviation, instead. So the t-score that we use when constructing a 95% confidence interval is the t sub 97.5% value, that column in the chart for the t-distribution. So let me open up that chart. Let's see. Okay, in your handout at the very, very end, you have this chart for the t-distribution, and we did look at this at the last lecture. And just to recap, the t 99.5 column is used when you want to construct a 99% confidence interval. The t 95 column is used when you want to construct a 90% confidence interval, and the t 97.5 column is used when you want to construct a 95% confidence interval. So you could make notes on this handout if you want. However, when you take the final exam, I'm going to give you a fresh copy that's not going to have any notes on it, so you may want to make these kind of detailed notes on your note sheet that you'll be taking to your final exam. So we're not going to use any column other than this one, and this one. So going back to our PowerPoint, we have to find out which t-score works when using 35 degrees of freedom. And the answer is 2.04. Now you may ask why, because if we look at that chart and we look at 35 degrees of freedom, remember that degrees of freedom is always n minus 1, so 36 minus 1 is 35. If we look at 35 degrees of freedom, you're not going to find it. You see 30 degrees of freedom and you see 40 degrees of freedom. And also, we're creating a 95% confidence interval, so we're looking at the column labeled T97.5. So T97.5 right here, going down to the row labeled 30 or 40. Notice that there are two different t-scores. We have one for 30, 2.04, and one for 40, 2.02. So it's confusing which one to use. Do we use the one for 30 degrees of freedom or for 40 degrees of freedom if 35 is not found on the chart. And there's going to be a rule that we're going to follow regarding degrees of freedom when you don't find the value on the chart. In this case, we're going to use 2.04. When the degree of freedom is not on the table, we have a choice between the two surrounding degrees of freedom. So we have a choice of 30 or 40. And the rule is to always choose the smaller of the two. You're always going to choose 30 over 40. And if you look at the next grouping, 40 to 50, if you happen to have degrees of freedom 44, you're always going to choose 40 over 50. The reasoning for this is if you look at the number if you compare 30 to 40, the t-score for 30 is a lot bigger, well, not a lot bigger, but it's bigger than the t-score for 40. A larger t-score is going to produce a wider confidence interval. A wider confidence interval is a more conservative estimate, and we always want to err on the side of a more conservative estimate over a less conservative estimate in statistics. We don't want to say we're 95% confident if the number is only going to give us 94% confidence, for example. So we always want to say we're 95% confident, and perhaps our interval gives us more than 95% confidence. That would be great, but we should never give an answer that's less than 95% confident. And that's exactly what would happen if we use the 2.02 instead of the 2.04. So we're going to be using the 30 degrees of freedom for this one, so it's 2.04. And if we go to the formula now, and we plug in the values that we know, the mean is 4.6, we use a t-score of 2.04, standard deviation of 1.4, and the n is 36. Plug that into your calculator. I'm going to do it too. If we plug that in, okay, so we have 4.6 minus 2.04 multiplied by 1.4 divided by the square root of 36. So square root of 36. Now you may realize that the multiplication is not something that's in my PowerPoint presentation, but it is going to be required when you use the calculator. So your lower limit, 4.124. And look what happens if, instead of 2.04, I use 2.02. .12, which would be 129 if I rounded to 3 places, or 1287 if I rounded to 4 places. If you compare these two values, this one, 4.124, is smaller. So the confidence interval left side boundary is smaller here than it is here. This is the more conservative estimate, and that's the one we're going to go with. So that's why we pick the 2.04. Okay, so finding the upper limit, we're going to change the minus to a plus and change this back to 2.04. Change this to a plus, and we get 5.076. So on the lower end, our confidence interval is 4.124, and on the upper end, 5.076. So to interpret this, we're going to use our standard interpretation for a confidence interval. We're going to say that we are 95% confident that the true population mean number of typing errors per page is from 4.124 to 5.076. And if we want to find the margin of error, we simply take the upper value, subtract the lower value, and divide by 2. So we take 5.076 minus 4.124, divide by 2, and our margin of error is 0.476. So the relationship between the margin of error and the confidence interval, if I go back to 4.6, our sample mean, and I subtracted the margin of error, I'll get the low end of the confidence interval. And if I go to our sample mean, 4.6, and add the margin of error, I get the upper limit of our confidence interval. So the sample mean plus or minus the margin of error gives us the range from 4.124 to 5.076.